Alright, here is my audio amplifier from ECE 323. As you can see, it's in a box, it's clear, and has electronics in it. So, the system overview, we have audio in coming from the computer, as well as USB coming from a computer, going into a pre-amplifier, then the buffer, and then the power amplifier, finally to the speaker. And then there's two channels of this, so the circuit is repeated twice on the board. And so here's what the circuit looks like. We have the preamp, buffer, and power amplifier. The preamplifier is a common collector with emitter resistor, as well as these R1, R2s. It's biased to 2.5 volts at the output, so this node here, right before the capacitor, should, at 0 volts AC, it should be at 2.5 volts DC, and so that gives it a max up-down swing of 2.5 volts to the top and bottom, because it's between 5 and 0 volts. Also, the IC at DC should be about 1 milliamp, and so these resistors are chosen to bias to that. And that's assuming 5 volts VCC. The two capacitors are DC blocking capacitors, so that the AC signal can pass through, but the DC from the power rail does not pass through the capacitors. The buffer stage is needed because if the output stage were connected directly to the preamplifier, it would draw too much current and drop the voltage, which would distort the signal a lot. So the buffer stage buffers the voltage and gives enough current draw so that it doesn't drop the voltage. So this is an emitter follower, also biased to 2.5 volts at the output on the emitter, and that's assuming 5 volts again. You'll notice it's two transistors, so it's a Darlington pair. That's because the beta of a single transistor is not enough gain to do this. So it's using two transistors in a Darlington pair in order to multiply that beta to get a large beta for the current draw. And then again, there's another DC blocking capacitor between the buffer and the output stage. The output stage is a class AB power amplifier, so we need a power amplifier in order to drive the speaker, which is an 8 ohm 0.3 watt speaker. So the power amplifier design I found looks like this, and so the resistors were chosen to have a low input impedance of I think about 100 ohms. It's made up of an NPN transistor and a PNP, so the O1 and the O3. And so these two diodes are required to, without them there is a crossover distortion of the two transistors, and so these diodes are chosen to match the diode drop of the transistor. So there's the diode drop at the arrow, and then the diode drop of the diode I put there. So the two diodes match that diode drop in order to remove that crossover distortion, at least to some degree. It would work better if I just used the diode-tied transistors that are identical, because that diode drop would be mostly identical. And then there's a final capacitor for the output to the speakers, and that is the output stage. The improvements I made to the circuit, I made an enclosure and a small circuit improvement. So the circuit improvement takes the USB input, VN, it goes through this jumper to VCC. So the jumper is connected to a switch that is part of the knob, so that way you can turn off the whole circuit, because this is right on the voltage input, there's a switch to turn it off. Then VCC is bypassed with this capacitor. It's actually a 10,000 microfarad just to buffer that the voltage, so if the circuit draws like a heavy bass sound, it draws too much current, the capacitor should hold some of that and also filter some of the noise. And so that's jumpered to the main board so that the main board has access to power. Also, VCC is connected to this microcontroller, which is going to drive this RGB LED. So the main purpose of the LED is power indication, but also the microcontroller will let me use pulse width modulation to just kind of phase it in and out of its different colors to give it a cool glow. The board was made, the power board and main board I made starting with a blank copper board. You take photo paper and print the PCB traces on a laser printer, and the toner will not fully will not fully like soak into the paper, so you can transfer it onto the copper using heat. So about 10 minutes on an iron and the toner is transferred to the copper. Then you dip that in PCB etching solution, which is an acid that eats away the copper, but the toner protects the traces, so when you're done and clean it all off, you're left with just the copper traces. And so once you drill the holes, your PCBs are complete. This main board I made double-sided, which was actually quite, I was quite impressed that I was able to line the holes up. I didn't fully account for trace width or pad size, so some of the parts covered the pads and made it very difficult to solder. When I first tested it after soldering everything together, it didn't work, so I just abandoned this board and went back to the prototype board, just because I didn't want to put in the effort to debug this board. I did, however, use the power board, which has the microcontroller LED and filter capacitor. And so the enclosure was made in SolidWorks. Here's the front of the enclosure. We have the two speakers and their drill holes and the knob cut out. And then the back, since I didn't know which board I was going to use in the final version, I had just had the back open, so that way either board can be fit in, and I didn't have to make a final decision on like a panel cutout. And it also made it easier to access and screw in the speakers, because I assembled the box before putting the speaker in, and I was able to do that because of this open back. The tabs on the side were to lock the pieces in place, but I didn't quite account for them on the sides, and so the original sides had tabs similar to the others with the indented ones, but I removed the indented ones and resized these to fit in afterwards, because the original sides did not fit in with the box. But so yeah, this was made in SolidWorks and sent to the TechPlots to be laser cut. I was going to laser cut it on plywood, but they no longer support that, so they cut it on clear acrylic for me, and that is what the final version looks like. The PCB was assembled using hot glue as the adhesive. I could have used acrylic cement, but I figured hot glue would hold it, and that's what I had. I didn't have to go purchase acrylic cement. So yeah, there is the final version.